Hi there, intermediate algebra students. It's time for another online lesson. Today is 12-3, dividing rational expressions. And again, remember that this is just like dividing fractions. And as you recall from doing that, you never actually divide. You end up multiplying by the reciprocal. Okay, and you might remember what a reciprocal is, just the flip of a fraction where the numerator becomes the denominator and vice versa. All right, let's just try a couple examples. First one here is a pretty easy one from earlier, 2/3 divided by 8/9. Remember, never change the first fraction, that stays the same, but then I'm going to multiply by the reciprocal, which should be 9/8, like that. And then I'm going to do a little canceling or reducing. I can divide by 3 here. That becomes 3 in the numerator. I can divide by 2. That becomes 4 here. Now I can multiply across and my answer becomes 3/4. So we've done things like that. But now let's try doing it with actual polynomials and variables included. So look at this next example. Now notice the first fraction doesn't change at all. That stays as negative n squared over 6. But then I multiply by that reciprocal, which in this case will be 12 over 4n cubed. And now I see if I can do any reducing once again. And sure enough, I notice that here's 6. 6 goes into 12 2 times. And I have some powers of n here. Here's n squared. I can divide by that. And then this will become n to the first in the denominator down there. Now when I multiply across, it looks like in the numerator will be negative 2 as you multiply across. And then in the denominator, I still have that 4 there, which I kind of forgot about, over 4n. And I can even reduce that a little bit further, as 2/4 will reduce to negative 1/2. So my final answer becomes negative 1 over 2n, like that. Right? Let's take a look at some more complicated examples here. Here we have full-fledged polynomials, as you can see. So let's take a look at the first one. So again, I'm going to leave that first fraction exactly the way it is, so x over x plus 5. I'm going to multiply this time by the reciprocal, so I'm going to flip these, that fraction right there, so it becomes now x plus 5 over x minus 7. And can I do any canceling or reducing here? Well, remember, it's a little bit tricky now as to where you can cancel variables and where you can't. But right here, when I have that x plus 5, that's a whole expression there, a little binomial. I can cancel those out. Now, can I cancel these two x's? This one and this one? No, because of that subtraction sign right there. Remember, the only time you can cancel is if you have multiplying and dividing, which I don't in this case. So now I just have to multiply across. Remember, whenever you do cancel, it becomes a 1 if you cancel the whole thing. So when I multiply across numerators and denominators, my final answer here becomes x over x minus 7. All right, let's take a look at the next one here. So again, I'm going to leave that first fraction the way it is, so 5a plus 10 over a plus 5. Now you need to think of this dividing by a plus 2 as a plus 2 over 1, because now when I multiply by that, it's going to become 1 over a plus 2. Now at first glance, this may not look real promising as things that I can cancel or reduce. However, remember, just like last lesson, we can do a little factoring. So in fact, I can factor my numerator here, 5a plus 10. The first thing we always look for, remember, is a common factor. And sure enough, it does have a common factor of 5 And using the distributive property in reverse, then that becomes a plus 2. A plus 5 is still in the denominator. Now I'm multiplying by 1 over a plus 2. And now, sure enough, you can see that now I do have something that I can cancel out the a plus 2's here. Can I cancel out these two 5's? No. This one is multiplied, so it might be a candidate, but this one is not. It is added, so because of that I can't. So now it looks like my final answer should be, when I multiply across, 5 in the numerator, and my denominator is just a plus 5. Alright? A couple I'd like you to try right here. So if you'd like to pause your recording and try these two, please try them even though you might not be real sure about what to do. And then the next slide I will show you what the answer is. Alright, so here we go. Let's try these. First one, of course, a pretty basic one. It's got variables in it. Leave the first fraction the way it is all the time, but I multiply by the reciprocal, which is y over 2. I can do some canceling here now. My y's will cancel out. Remember, when you do that, that just becomes 1. And sure enough, 2 will go into 6. When I divide by 2, I get 3 up here. So my final answer then, when I multiply across, is indeed 3 over 1. And we would just write that as 3. Now, next one, a little trickier. Let's see what we could do here. Again, I'm going to leave that first fraction the way it is. So k squared minus 5k, nice k there, plus 6 over 5. I'm going to multiply now by 15 over k minus 3. Again, this looks a little suspect as to what I can cancel until I remember that I can do some factoring. So let's think about that. And the thing I can factor is this original numerator. No common factors there, but this is a trinomial, and so I can break it apart into these two binomials, k and k. And then in this case, it's going to be minus 3 minus 2. Use your FOIL method, your double distributive property, and you see that's what it ends up to be. Now, again, this is my numerator, so now notice that I can actually do some reducing here of this k minus 3 and this k minus 3. And here's a 15 and a 5. I can divide those by 5. And so now my final answer when I multiply across is 3 times k minus 2. That's going to be in the numerator. Meanwhile, my denominator looks like it's just going to be 1. Everything else is canceled out. So there's my answer right there. Now, somewhat of a practical use of this. Let's take a look at this. There's Nick racing down the slopes at breakneck speed. Let's say he's going 70 feet per second. Could we write that or convert that in miles per hour? Well, let's think about this. You might have done some things like this in science, perhaps. So let's think about this. Right now he's going 70 feet per second. We'd like to ultimately convert this to miles per hour. So let's think about this. You may remember that in 1 mile there are 5,280 feet, if you recall. And so now my feet are actually going to cancel out then when I multiply this. That's what I want. But now I have to somehow do a conversion so I can get hours in there. And we'll do it like this. There are 60 seconds in 1 minute. And of course there are 60 minutes in 1 hour. So now notice what happens when we cancel these out. Notice my feet, those units are going to cancel out. The seconds are going to cancel out here. The minutes are going to cancel out here. So notice what I have left will be miles per hour. That's what I want. And so then I'll just multiply those across. and then I'll be able to divide, and then I'll get my answer. And I think when you do this, this will end up to be about, whoops, let me get my pen here, about 47 miles per hour. So pretty fast speeding along there for jolly old St. Nick. All right, thank you very much. We'll see you guys in class tomorrow.